Hi, it's Mr. Oliver, and we're talking about significant digits. We can also refer to this as significant figures, and I'll be using both terms interchangeably. They do mean the same thing. This video, along with the one on scientific notation, are not connected to any particular course or not connected to any particular unit in science, but they are all about overall scientific numeracy, understanding how numbers work in science, because sometimes it is a little bit different than in math. What are significant digits? We need to know that there's two types of numbers in science. There are exact values, and exact values are things that we have either counted, numbers of fingers on a hand, number of atoms in a molecule, or they're values that have been defined for us. So in the example I have here, 1,000 milliliters is 1 liter. And this has been defined for us, and we're absolutely confident that 1,000 milliliters is 1 liter. It's not something that we've had to figure out ourselves. We can also have measurements, and measured values are going to have some uncertainty. And the amount of uncertainty depends on the graduations. In other words, how precise is our measuring device. And on the left I have a centimeter ruler, and on the right I have a millimeter ruler. Now you'll notice that the millimeter ruler, of course, has more graduations, more little ticky marks. The gaps between your big divisions are divided up even smaller, so we can have a more precise measuring tool. Now I've used the word precise and we've used some terms uncertainty, so let's make sure we understand all our terms. We have the term accuracy, and accuracy is kind of important. And accuracy is how close the measured value is to the true value. So it's a comparison between those two things. Now in chemistry, we're going to be talking about theoretical values. And theoretical values for us are going to be the same thing as the true value. We're also going to have experimental values. And experimental values are always the ones that we have measured. So for us, measured values and experimental values mean the same thing. True value, theoretical value will mean the same thing. Now, of course, what we want is our experimental values to be very, very close, hopefully exactly what our theoretical values are. But it's not likely going to happen. And part of the reason why it won't happen is because of things like significant digits. I also use the word precision. And precision sounds kind of complicated when you read it. It's the place value of the last measurable digit. But it's going to make some sense, because if I look at the different tools that I have to measure the same thing, I'm going to have in, say, for the case of a thermometer, maybe one thermometer, the best I can measure is 15 degrees Celsius, where a better thermometer, maybe I can measure 15.3. So it's all about the device I've used to measure it, and that last measurable digit. Was I able to measure to the 0.3 or not? If we put it into pictures, we have a target here where, let's say, the red bullseye represents the true value, and the yellow dots represent the experimental or the measured values. And in this one I have a case where it's not accurate because they're scattered all over the place and they're not precise. So they're not close to the center and they're not close to each other either. On the other hand, if I move on to this picture, I have a fairly tight grouping, but they're not close to the center. So the fact that they're not close to the center means that they're not accurate, but they are precise. They're close to each other. Moving on, I've got a case where the yellow dots are now close to the center, but not very close to each other. They're a fairly wide grouping still, but they're right around the middle. And then finally, I have the best possible result in that I have a nice tight grouping right around the center. So we have both accuracy, close to the center, and precise, close to each other. And that's really what we want to achieve. If you were given a red bar and a centimeter ruler, you might say, well, if I had to estimate that, I know it's more than 2, it's probably not quite 2.5, maybe you would guess it to be 2.3 centimeters. Notice that I can be fairly confident about the 2, but I had to make a bit of a guess on the 3. If I bring out that millimeter ruler again and measure the same bar, you could look and say, well, it's a little bit more than 2.3, but not quite 2.4. Maybe I'll guess it to be 2.36. Again, I have confidence in my part of my measurement, and then I had to make a guess at the rest of it. How do we know how many digits are significant whenever we're given a number to work with, or whenever we're given a tool to measure something? It comes down to a set of rules, and these are rules you want to be fairly comfortable with. These are rules you want to be able to know fairly quickly, that when you're given a number and you're asked how many digits are significant, or you have to use that measurement, then you'll know right away how many digits indeed are significant. So if you're thinking about writing down some rules, here's some good ones to write down. Leading zeros, not significant. So in this case here, decimal 0041, only the 4 and 1 are significant. Those leading zeros are not significant. Trailing zeros, well, it kind of depends. In the first case here, I would argue that there's only 2 that you know for sure to be significant. It's possible that the measuring device was able to measure up to 4, but you don't know that for certain. So the only thing you can really know for sure is the 2 significant digits. On the other hand, with this 10.0 centimeters, the fact that somebody has gone out there to take the trouble to write down decimal 0 suggests to me that the measuring device that they were using was able to measure into that millimeter column, that 1/10 of a centimeter. So I would say that that one does indeed have 3 significant digits. In the case of scientific notation, all of the digits in that main body of the number are significant. And as a quick aside, if I were to take this number back here, the 6400, that had some ambiguity, maybe it's 2, maybe it's 4, if that were written in scientific notation, then I wouldn't have the ambiguity. So for numbers like this, if they're written in scientific notation, it's actually a better way to express numbers. That way we're more confident on the number of significant digits. And finally, if we do have a counted value or a defined value, if we do have an exact value, those are considered to have an infinite number of significant digits. And the reason that's important is every once in a while we're going to be doing mathematical operations involving both measured values and exact values. So we want to only consider the significance, the significant digits, I should say, of the measured values. Well, what kinds of mathematical operations do we do, and how do we handle significant digits when we are doing them? There's 2 types: addition, subtraction, and multiplication, division. For addition, subtraction, we are going to round our answer according to the value with the least amount of precision, which is a fancy way of saying fewest decimal points. So if we look at an example, I could look at this and say 2 significant digits, 3 significant digits, 4 significant digits. Well, what do I do with this? What I want to do, though, is I want to look for the fewest number of decimal places. So 1 decimal place, 2 decimal places, 3 decimal places. And then my final answer is going to be controlled by the one that has the fewest. So I round my answer off to 1 decimal place. For multiplication division, it's kind of similar in the sense that I want my answer to be controlled by the least precise number, but I do it a little bit differently. I'm going to round my answer to the fewest number of significant digits, or fewest number of sig figs. And so it becomes a little bit easier, because instead of having to count decimal places, I only have to scan through and say 3 sig figs, 2 sig figs, final answer, 2 sig figs. So it's a little bit easier. Now, if you go to the course web page, you'll find a link to a quiz, an online quiz on significant digits. And it's going to have questions on simply counting significant digits, and it will have questions on doing mathematical operations with significant digits. Please give it a try. Make sure you're comfortable with it. And that way, when we're doing labs, when we're doing questions, when we're doing calculations in class, you can just go ahead and do significant digits and without even really thinking about it all that much. Thanks for watching, and enjoy it all.